Hey, ladies and gentlemen, we're talking 7-3 today. 7-3 is scientific notation, but this isn't just your normal pre-algebra 7-3 of scientific notation. This is algebra scientific notation. Whew. All right, so the same rules apply that applied in years past for you. So this is just a quick review of what I have written down on the right side of your Cornell notes. Big idea here is that remember that scientific notation is the ability for us to write really, really large or really, really small numbers in a more efficient manner. So these are things that we need to make sure that we understand, and all of them will be discussed here very quickly when we do our examples. So, for example A, our job is to create a decimal point that is normally at the far right of the number, or if it's not shown, it's at the far right of the number. And we're going to create it so that it's a number between 1 and 10, or 0 and 10. So it's going to be something point something. So in this case, our first number, this very large number where it's a 4, 6, 2, and a bunch of zeros, this is thousands, millions, billions, trillions. So this is 4,062,000,000 or billion. And our job is to then create this so that it's a smaller number. So we're going to count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there's 12 spots. Now you might have done in the past making these little whoop-de-woos or waves or whatever the heck you might have called them so that you can count. But the commas can help us skip count by 3. So 3, 6, 9, 12. So this is the new location of our decimal. So for me to be in scientific notation, I have to say something point the other numbers. And I stop writing things when we have our repeating zeros. And it's going to be times 10 to the power of however many times we move the decimal. Now we made this really, really big number really, really small, so it's going to be a positive exponent of 12 because we said 3, 6, 9, 12 times that we moved it. All right, example B, same exact idea. The decimal point was here. We're going to move it so it's, again, something point something else. We moved it 1, 2, 3, 4, 5, 6, 7 times. So we have an 8.23 times 10 to the negative 7. Now we made a really, really small number bigger, so that's why we have a negative exponent. Now it's really important, folks, that again we understand how we're counting here. The times 10 stuff is because the number system that we work with is a base 10. So every 10th number we move over to the 10th place, the 100th place, the 1000th place. So it's the same idea that we deal with our place value. All right, let's make things just a touch harder. We're going to change from a regular scientific notation and change it to a standard form number. Again, up here are our rules as to how we know if it's positive or negative, and I'll try to simplify that even further with, let's go with this color, our process here. So our job, it was 6.49, and the exponent tells us how many times to move it. So it's 1, 2, 3, 4, 5 times because if it's a positive exponent, we move to the right, we're making it bigger. So we have open spots fill in with a circle, or a 0, I'm sorry to say that one, and we just fill in our numbers. Now I like to have my numbers without the whoop-de-woos or the waves so that we can specifically see that this is 649,000. Okay, letter B, same process, 1.8. We're moving it a negative 3 times, so it's going to move to the left. Let me erase so that I have better space to do this. We're going to move to the left 3 times. 1, 2, 3. Open spots fill in with a 0, so we have a 0.0018 would be our official answer. And that's how we change scientific notation into standard form. Remember, standard form is the way that we normally see numbers. Let's make things harder, because this is the not your average pre-algebra part. This is the algebra part of scientific notation. Really intense. All right, the process here when we're multiplying two numbers of scientific notation is very useful the way that we talked this last couple lessons. I'm going to multiply. There's like terms here that we're going to deal with. We have a 5 and a 2.3, just regular numbers, and then we have our 10 to some power numbers. So we're going to multiply those two things that are alike together. So in our trusty calculators, 5 times 2.3, I get n, so we're multiply those two, we got a 11.5. Now we're going to multiply our exponent stuff together, and remember that when we multiply we add, so this becomes a times 10 to the 6th power, because a negative 6 plus 12 makes a positive 6. Now this number is not in scientific notation yet, so we're going to move the decimal one time to the left to make it in scientific notation. So this is now a 1.15 times 10, and now we have to think about this one, folks. It was a 6 and we made our number smaller. So what do we do before when we move the decimal to the left? We then increased. So this is a plus 1 up here because we moved it one more time. Oopsies, I did the answer there. Plus 1. So now this is a 10 to the 7th. And one way to make this a little bit easier for us, we made this number a smaller number, so to counter that we had to increase our exponent. So that's the way that my brain actually thinks, which is kind of weird. I shouldn't let you inside my brain. Alright, same exact idea here, except for we're dealing with division. So when we divide just our regular numbers and then we divide our exponents. So a 4.5 divided by a 1.5, and I get a 3. 8 times 10 to the 8th and 8 times 10 to the 10th. We subtract those, so we're going to get a times 10 to the negative 2nd. Now my decimal is in the correct spot, so I am automatically done. So my answer is 3 times 10 to the negative 2nd. Now we are in scientific notation right here, but if we put it into standard form as well, that's going to be 2 times to the left. We're going to have a 0.03 would be our standard form of this number. Did I forget to do that for the other one? Oh no. And standard form. Let's move it again. So it's going to be 1, 1, 5, 1, 2, 3, 4, 5, 6, 7. I forgot that. So it's going to be 115 million. Oh, I did that wrong too. Don't tell anybody. Here we go. Let's fix it. 1, 2, 3. It'll be 11.5 million. Just the amount of money that I will make this week off of this specific YouTube video, because tons of people watch this stuff. All right, folks. So again, this is the big idea. We will have a few practice problems when you return to class, and we wish you the best of luck. Peace out.